In this video, we will learn about second law of thermodynamics. Okay, what is second law of thermodynamics? So, actually, first law of thermodynamics is just a thermodynamic interpretation of maybe you can say law of conservation of energy. What is law of conservation of energy? It means the energy entering into a system and energy leaving from that system is always constant. Or if there is a transformation of energy, then energy before and after they are equal. Okay, let's take just an example of human body. If your body is receiving 5 units of energy, and then maybe when you do some work, okay, you consume 4 units of energy, okay, in the form of work, and 1 unit of energy may be stored in your body, okay. And maybe you can also say that this energy is not just only in the form of work, it may be also in the form of heat generated in your body. Okay, so this is basically conservation of energy principle for human body. So first law of thermodynamics, it's very quite simple. Okay, uh, let's suppose you have a system uh, with an ideal gas in a cylinder. uh, you supply some heat, okay, आप इसको कुछ हीट सप्लाई करते हैं, देन व्हाट इज फर्स्ट लॉ ऑफ थर्मोडायनामिक्स, दैट इस अब इस हीट का कुछ पार्ट जो है वो वर्क करेगा, रेस्ट पार्ट जो है वो इसकी इंटरनल एनर्जी इंक्रीज कर देगा, ओके। So first law of thermodynamics is very simple. The change in internal energy of a system is equal to the heat added to the system minus the work done by the system. यानी कि हम अगर इस सिस्टम को जो भी हीट हम सप्लाई करेंगे, ओके, उसका कुछ पार्ट जो है वो वर्क करेगा, रेस्ट ऑफ द पार्ट जो है वो इसकी इंटरनल एनर्जी इंक्रीज कर देगा, ओके। यहाँ पे इसने जस्ट एक प्लस का साइन लगाया गया है, यहाँ माइनस का साइन लगाया है, प्लस माइनस दोनों हो सकते हैं जब हम, देन वी हैव टू टेक द कन्वेंशन दैट क्यू क्यू इन एंड वर्क इन, दे आर बोथ आर पॉजिटिव, क्यू इन and work in both are positive, Q out and work out they both are negative from the system. Okay, so this is simply first law of thermodynamics. It's quite simple. Okay, now let's move to the second law of thermodynamics. Basically it's quite difficult. स्टूडेंट्स के लिए जो सेकंड लॉ ऑफ थर्मोडायनामिक्स है उसको समझना थोड़ा सा मुश्किल होता है, ठीक है। चल अगर इफ यू टेक सम एग्जांपल, आपके पास कोई कॉफी का कप है, ठीक है, या टी का, दैट इज टेम्परेचर इज मे बी यू कैन से इट्स मे बी 70 डिग्री सेंटीग्रेड, ओके। इस टेम्परेचर इज 70 डिग्री सेंटीग्रेड, तो क्या होगा आफ्टर सम टाइम, अगर आउटर साइड टेम्परेचर लेट्स सपोज 25 डिग्री सेंटीग्रेड है, तो हीट विल मूव इन दिस डायरेक्शन, यानी कि आपकी जो टी है वो थोड़ा सा कोल्ड होना शुरू हो जाएगी और हीट विल मूव फ्रॉम दिस कप ऑफ कॉफी इनटू द एनवायरनमेंट। जी, सो ये आपका सिस्टम है, दिस वन, एंड बाकी आपकी ये सराउंडिंग्स है। तो नाउ लेट्स थिंक, ओके, सो नाउ लेट्स थिंक कि क्या ये रिवर्स में ये प्रोसेस हो सकता है, कि ऐसा पॉसिबल है कि कॉफ़ी जो है वो आपके एक रूम में 25 डिग्री सेंटीग्रेड पे पड़ी हुई हो और वो दोबारा हीट हो जाए ऑटोमेटिकली? नो, ऐसा क्या ऐसा पॉसिबल है कि आपकी जो कॉफ़ी है वो दोबारा हीट होना चाहिए ऑटोमेटिकली विदाउट डूइंग एनीथिंग? सो रिवर्स प्रोसेस कैन नॉट हैपन स्पॉन्टेनियसली, ओके। नो एक और एग्जांपल लेते हैं। Let's suppose you have some air at high pressure Pi in an in a box, and then outside pressure is P naught. You make some hole here. Okay, when you make some hole, so definitely the the air pressure in this box container will start decreasing. Okay, and after some time the pressure inside the box will be same as outside pressure. Okay, environmental pressure will be equal to the to the pressure inside the box. So let's think about this example also. Can this reverse process happen automatically? No. Okay, no. Air cannot enter into a chamber at high pressure without any external work. That is just a common observation in your life कि ऐसा possible नहीं है कि heat जो है वो सॉरी हाई प्रेशर वाले कंटेनर के अंदर एयर जो है वो खुद ही उसका प्रेशर इंक्रीज करना शुरू हो जाए। ऐसा आपको यू हैव ऑब्जर्व कि ऐसा बिल्कुल भी पॉसिबल नहीं है। ओके, लेट्स मूव। इसी तरह लेट्स टेक एन अदर एग्जांपल। if you do some work by user rotating this device in the water, maybe the heat will be generated within this fluid. But if you supply heat into this to this fluid, as this is not possible that this will start rotating. Okay, work can always be converted to heat directly and completely, but the reverse is not true. Let's take another example. Okay, if you have a weight at higher altitude, you drop the weight, then weight will come down in due to gravity. Okay, so is it possible? Let's again think that you do not do any work and weight start going up. No. Okay, that is not even also possible. A mass cannot move itself against the gravity force field. So mass cannot move itself in the upward direction. Okay, so you have seen all these examples. uh, Let me show you all these, one, two, three, and there are so many other examples like this. So if you connect to if you connect to plates, like one is hot plate and other is the cold plate, you will also see that heat will flow high from the plate at high temperature towards the plate at low temperature. Heat will flow in this direction automatically, but it will not flow automatically in this direction. Okay, there's all these examples you can see, and these are the just your daily life observation. ये जितनी भी मैंने अभी आपको एग्जांपल बताई हैं इसमें ये सब जो हैं वो आपकी डेली लाइफ में आपकी ऑब्जर्वेशंस हैं जो जितनी भी हैं। ओके, first law is concerned with the quantity of energy. Okay, the first law of is concerned with the quantity of energy, that how much quantity of energy you have supplied to a system. Okay, and what how much proportion is the work done and how much proportion is the change in internal energy. The second law determines the direction of energy during a process. So what is related to second law? You have also seen in. So a process cannot occur. What we have concluded from now your previous examples, that a process cannot occur unless it satisfies both the first and second laws of thermodynamics. A process cannot happen unless it satisfies both first and second laws of thermodynamics. No process can happen. That is the rule. Okay. So what is uh, the statement of second law of thermodynamics? Clausius statement is it is impossible for any system to operate in such a way that net result is an energy transfer by heat from a colder to a hotter body. Okay, there is no such a system that can transfer heat from a cooler to a hotter body. Okay, now this is the statement of second law of thermodynamics. Now let's based on our previous examples, let's talk about this statement home that we call refrigerator. ये रेफ्रिजरेटर है। ओके, हम यूज वाई वी यूज दिस रेफ्रिजरेटर। ओके, पर्पस क्या है इसका? कब हम यूज करते हैं? व्हेन यू सी आउटसाइड टेम्परेचर इज वेरी हाई, देन वी यूज द रेफ्रिजरेटर। ओके, and why we use it? a device used to transfer heat from a low temperature region to a high temperature region. The working fluid is called refrigerant. So why we use that refrigerator? We want to transfer heat from this box into the environment, okay, into the high temperature environment. This is low temperature and we want to transfer q heat into the high temperature environment from this box, okay. So in actually what is how this is accomplished, कैसे ये प्रोसेस हो रहा होता है रेफ्रिजरेशन साइकिल, और जिस साइकिल पे बेस ये करता है उसको हम कहते हैं वेपर कंप्रेशन साइकिल, ओके. In order to understand about the refrigeration, there is another video in which I have uh, explained the refrigeration system in detail. Okay, you can see that. So basically, it have four components: compressor, this one, condenser, expansion valve, and evaporator. So basically we are removing heat from this box into the environment. Heat is absorbed here and heat is removed out here and work is done here. It means power is input in this compressor. How it is happening? Here we have evaporator coils. Refrigerant is flowing in this in these tubes. Okay, like this one. Evaporator coils removes heat from the air or this box. Evaporator will absorb heat from here, and then this refrigerant will go into the compressor and cold liquid gas pulled in. Usually in common language we call refrigerant as gas. हमारे जो कॉमन लोग होते हैं वो मोस्टली इसी को गैस ही कह रहे होते हैं, टेक्नीशियंस जो हैं, ओके. तो गैस जो है देन वी विल कंप्रेस इट बाय यूजिंग एक्सटर्नल वर्क, ओके. हॉट इस देन इसका टेम्परेचर एंड प्रेशर विल बी इंक्रीज्ड. ये ऑलमोस्ट मे बी 90 डिग्री सेंटीग्रेड तक इसका टेम्परेचर जो है वो इंक्रीज हो चुका होता है, ओके. एंड देन इन द कंडेंसर heat is rejected out and then there will be a sudden why expansion here because of Joule-Thomson effect and the sudden cooling, sudden expansion happens here. और उस sudden expansion की वजह से हमारे पास यहाँ पे हीट सॉरी बहुत ज़्यादा कूलिंग प्रोड्यूस होती है और टेम्परेचर में भी -22 डिग्री सेंटीग्रेड तक डिक्रीज कर जाता है, ओके. So then this -2 will absorb uh, heat from this evaporator. So this -2 degree centigrade uh, refrigerant will absorb heat from this cold chamber here, evaporator inside this box, and then again the cycle will start. So this is just an introduction of a vapor compression cycle. Okay, so what was the Clausius statement? It's impossible for any system to operate in such a way that the net result is an energy transfer from a to a hotter body. It means it's not possible for any system to transfer heat to a from the cooler to a hotter body or the region. When a heat transfer from a cooler to a hotter body occurs, there must be other effects within the system accomplishing the heat transfer, and its surroundings are the both. So, whenever this is happening, there must be some other effects also. Okay. So in very simple word, you can say a refrigerator cannot operate unless the compressor is driven by an external power source such as an electric motor. So in very simple word, if you will say कि जो आपका रेफ्रिजरेटर कैनॉट ऑपरेट अनटिल इस जिसका जो कंप्रेसर है हम उसको रन करें विद एन एक्सटर्नल सोर्स, ओके. So there is no such a refrigerator that is let's suppose take this example that is transferring heat 5 megajoule from the cold refrigerator space to warm environment without doing any work. So there is not no such a system that is not do. There must be some external work. So that is the basically statement of Clausius statement of second law of thermodynamics, that in simple words, a refrigerator cannot operate until its compressor is driven by an external power source such as an electric motor. Okay, that, and this is the thermodynamic statement. Okay, so if you have any question, you can ask in the comment section. Thank you.